Welcome to Explaining the Digital SAT one question at a time. We're talking about practice test 1, math module A, question number 27. All right, here we have an equilateral triangle, and we're given the perimeter, and we're asked to find the height. Now, to answer this question correctly, you really have to know your 30, 60, 90s. Why do you need to know your 30, 60, 90s? Well, an equilateral triangle consists of two 30, 60, 90s back to back. And if you take an equilateral triangle and divide it in half using a perpendicular bisector, you're going to get two 30, 60, 90 right triangles. Now, if you remember your 30, 60, 90 right triangles, you'll remember that the sides have a ratio of x to x root 3 to 2x. And if you think about it in relationship to the equilateral triangle, it makes complete sense, because after all, this perpendicular bisector is bisecting this opposite face. So if the sides of the equilateral triangle have length 2x, then the length of this bisected opposite face is going to be x. So now we can see the relationship between equilateral triangles and 30, 60, 90 right triangles. Let's apply them in this specific case. All right, so here I've drawn the equilateral triangle, and remember it has a perimeter of 624, and 624 divided by 3 is 208. So if each side of the equilateral triangle is 208, then when we drop this perpendicular bisector, then we know the side opposite that's being bisected is going to be divided into two pieces, each of length 104. Now keep in mind the relationship between the three sides in a 30, 60, 90 right triangle here, and remember that the middle side, which in this case is the height of the equilateral triangle, is going to have a length of 104 root 3. And if the height of this equilateral triangle is 104 root 3, and that's equal to k root 3, then k must be equal to 104. And that's why 104 is the correct answer to this question.